Hello guys, welcome to my YouTube channel. So today we'll be solving Leetcode weekly contest 372 problem C 2939 maximum XOR product. Okay, so pause the video, read the question, then we'll proceed. Cool. So the question says that we'll be given three integers a, b, n. Now we have to return the maximum value of a's or x multiplied by b's or x, where x will be nothing but we can pick any number x such that it should be less than 2 to the power n. Okay, and answer can be right, can be very large, so we need to return modulo 10 to the power 9 plus 7. Okay, question is straightforward, very simple. So let's look at one example first. So what it is saying over here is if a is 12, b is 5 and n is 4, then we can choose any number less than 2 to the power 4, that is less than 16. So if we have chosen x is equals to 2, then a's or x, and our final answer becomes, like if we'll multiply it, our answer we get 98, and that is the biggest possible answer. So in that scenario we have 98 as our answer. Okay, now first of all, how we will proceed this kind of question? So the moment you see that something like this, azar or and anything like that means it is going to have, or we have to deal something related to bits. That's one thing for sure. Now second thing is we are seeing this 2 to the power n less than 2 to the power n. So there is one basic property that if we'll just have what n bits, then its total sum will be 2 to the power n minus 1. Okay, what I'm saying is, like if you'll have three bits, so that means 0 0 0, these three bits, so the maximum possible value can have 1 1 1. So that is nothing but, if we'll number it, or sorry, if we'll convert it into decimal, you will say it represents 1, it represents 2, it represents 4. Okay, so in total it's 7. So that is less than 2 to the power 3, or to precisely 2 to the power 3 minus 1, that is equal to it. So there is one, this is this property, I just wanted to point it out because we'll be kind of using it over here, one thing. Okay, so now coming back to the question, so we'll have to select x. Okay, and we have to maximize this product. Now how we'll proceed? So first of all, what you can see, that let's say if we have some a. Now what we'll do, we will convert this a from decimal to binary, just for our understanding. So let's say if our a was 12 from this question itself, let's say 12 and 5. So if a is 12 in decimal format, then in its binary what it will be, it will look something like this: 1100, right? Because this will be 1 2 4 and 8, so 8 plus 4 12. Okay, and b is 5, right? B is 5, so B can be represented as something like this in 4-bit format. Okay, now if we are clear up to here, now we have n as 2. I'm correct. Let me check. Sorry, n is 4. N is also 4. Okay, so n is also 4. So if we'll realize one thing, at the end, what we'll have to do? A XOR, A XOR, A XOR X. Okay, and we know that the property of XOR. So whenever we XOR two numbers, or specifically let's talk on the bit values. So if we have to take bitwise XOR, so if it is 1 and 1, then we will get 0. If it is 0 and 0, then it will get 1. Sorry, 0. My bad. And if it's 1 or 0, then in scenario we'll get 1, or if it's 0 and 1, then also we'll get 1. So if I consider just this one, a and x, so what I can do, if I have to multiply, we have to multiply, right, a's or x multiplied by b's or x. Let's say let's say if there was some bit, like, and there was some bit, for example here, this bit, and this bit, this was both, not, let me try it carefully. So for this bit, or the second bit, this is first bit, second bit, third bit, fourth. So for the second bit, we have both this bit set as 0, both this bit set as 0. So what we can see from here, or what we can say from here, is that the x we will be selecting should be such that, like, at least for this bit, this should be 1. Why? Why? Because whenever we will be calculating this value, right, a's or x, so we know that second bit of a is 0 and second bit of b is also 0. So if we'll set xor of or the second bit of x as 1, that means the value will increase, because whatever the value we have x, whatever the value we have for a, it will be increased. Why? Because this value will be set to 1. Initially it was 0, so in this scenario if we'll set this to 1, so then actual initially we had value 12, right? And now this 2 will also increase and a will becomes 14, or if represented in binary it will become something like this. Okay, similarly for b as well, the binary version will look something like this: 0 1 1 1 0, and this is nothing but sorry, I made a mistake here, it was 1, right? Initially it was 1, so it will nothing but 7. So we saw that the value increases, so that there is one thing, or we can say that whenever it's 0 and 0 we can make it 1. Now also whenever there is 1 and 1, whenever there is 1 and 1, what does that mean? That if we have 1 at any bit in A and 1 at any bit in B, then in that scenario we should choose our XOR or the ith bit of x as 0. Why? Because if we'll choose anything else, or that means if we choose 1 over here, then it will make both these values 0 and will decrease our answer. Okay, so from here what we realize, is that if for a and b, for both for a and b, if ith bit is 1 in both the scenario, then also it's good, we can leave it as 1. Or if both the bits are equal to 0, then we can make it 1 by putting that corresponding bit as 1, corresponding bit in x as 1. Okay, till here we are clear. Now the only problem arises if in, let's say, in a, taking the same example, in a if it is 0 and another one is 1, so what will happen if ith bit, if we're talking about ith bit, and let's say it's 0 and in b it's 1. Okay. So here we have two possibilities. If in x we will put 1, then what will happen? Then this will become 1 and this will become 0. But if we'll keep this as 0, if we'll put instead of 1 we put this as 0, then it will be 0 and it will become 1. So the only dilemma is when to choose, or like what to put over here. See, till now what we realize, that if both the bits are same, then we don't need to worry about, because we can make both the bits 1. Okay, if it is already 1, no need to worry about. And if it is both are 0, then we can put this x bit, or the ith bit of x is 1. But now if both are different, then we have two possibilities, whether to put 1 or whether to put 0. Okay, so before explaining to that when should we choose, let's do a simple thing. What I'm saying is, we have to choose two numbers, a and b. Okay, we have to choose two numbers such that their sum should be fixed, and that is, let's say, 17. Okay, that is 17. So what we can do, we can put something like this: 1 and 16, 2 and 15, okay, 3 and 14. Okay, what we can do again over here is 4 and 13, 5 and 12, 6, 11, 7, 10, 8, 9, sorry, here it will be 9, it will be 8, and basically it will start repeating, right? Because it will be 10 and 7. So eventually we'll have the same number, same pairs we already have. So here if you'll see the multiplication, if here you will see the multiplication, you will see that this is 16, this is 30. If we'll multiply this two, it will be 42. If you'll see over here, it will, how much it will become? 52. It will become 60. It will become 66. It will become 70. And it will be, how much it will become? How much it will become? 72. It will become 80. And here it is 10 and 7. Okay, so what we realize is, if we'll see over here, that the more we are going towards each other, I mean, see, here A is very small with in comparison to B, right? But if we'll see, as we are decreasing the difference, like if we'll see the difference over here, here the difference is of 15, right? The difference is 15. Here the difference is 13. Here the difference is 11. Here the difference is how much it is, 9. Here it is 7. Here it is 5. Here it's 3. Here it's 1. And again here it started increasing. Here again it's 1, and then it will go to 3, and this like this. So we saw that the maximum product is obtained when we have two numbers as close as each other when their sum is fixed. And this is a special property in maths. So if we have two numbers, then the product will be maximum. If and say, so the constraint is, if we have two numbers such that the sum is fixed, then and we can choose any a and any b such that the sum is fixed, then the best or the maximum possible product will be in the case when a and b are as close as to each other. So like here you can see the difference is only 1, so a and b are closest to each other. So coming back to the question, if we'll see in the question, what is happening, that if we have two numbers, right, the maximum product can be obtained if we keep them as close as to each other. Now back to the question, if we have these two numbers, right, so saying these two bits are different, that means let me make it a little bit more clearer. So I am saying that there were few bits in both a and b, and here it is 1 and here it is 0. Okay, so if you'll see, if I am saying that this bit is, let's say, fourth bit, this is fourth bit, that means the value fourth bit value will be 2 to the power 3, right? Because the first value is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. So the fourth bit value will be 2 to the power 3. That means the difference, uh, like we are not considering about these bits, let's say they are all equal. So in that scenario, what we can say, that the difference between these two will be 8. The difference between these two, a minus b, will be minimum at 8. It may be there can be some different bits and it can vary, but keeping this left side equal, we are not sure about the right side. So we can say that this bit is different, then the difference will be at least greater than equal to 8. Okay, now how can we use this information, or why were you talking about this? So if you'll carefully observe, what will happen, like on the left side either it can be 1, both 1, or both 0. So what can we say, like if it is both 0 or both 1, so we can leave this ones as it is, and these zeros can be converted to 1, right? So in both the cases this can be converted to 1. So considering that this is all equal and this is the first bit where we have the difference. Now there are two possibilities. If a is greater than b, if greater than equal to b, let's say, or b is greater than a, so there are two cases. So if a is greater than b, now this is the first bit where we have the different bits. So keeping our best guess, what we can say, that a is equal to b plus 8. Why? Because this was the fourth bit, right, and the value is 8 over here, or like the fourth bit is set, so the overall value it will contribute to the sum of a is 8, right? The total value of a, it will contribute 8. Else, and see, and in this scenario what we are considering, that this rightmost bit, all the bits are same in both the cases, in both a and b, so we can say that a is equals to b. Else if there is some more difference over here, then it might happen that a can be something, some a plus b, and if some values are different over here, then what can we say? What I'm trying to analyze one thing. So if I am at nth bit, n minus 1th bit till this first bit. So one thing we know, that the sum of n bits is nothing but 2 to the power n minus 1, and the value at this n plus 1th bit will be nothing but 2 to the power n. So we can see that this nth bit, the value of nth bit is always greater than the sum of all the bits, sum of all the bits on the right of it, on the right of it. So if 8 or 8th difference or this fourth bit was different, that means the difference we have here is 8. And at worst what can happen, at worst what can happen, that this all can be 0 and this all can be 1. So even then the difference will be nothing but at max of 7, at max of 7. So if we'll change this now, if we'll change this now, let me clear it. What I am saying is, so we have a and b. Okay, a and b, and we know that this is the first bit, which is different, and in positions this is the fourth bit. Okay, this was the fourth bit. Okay, now we know that here at this point we are sure that a is greater than b, a is greater than b, because these are all equal. Okay, these are all equal, so a is greater than b. And if we'll see now, if in the worst case what can happen, a can be equal to b plus 8, considering that these two both are equal. Or else what can happen is, this can be 0 0 0 and this can be 1 1 1. So in that scenario also, a will be greater than b, a will be greater than b. Why? Because we know that this value, the value of this bit will be greater than the value of all the bits, or the sum of value of all the bits in its right. Okay, so we know that we have, if we want two numbers to give maximum product such that their sum is fixed. So why we are saying that? Because if we'll switch this, if we'll put x, or the x we need to select. So in that x, if we'll put 1 over here, then this bit will flip. If we'll put 0, it will be as it is. So if the difference, if a and b are much apart, there is bigger difference, we know that their multiplication will be smaller. So what we'll try to do, if a is bigger, then we will unset from a and set it to b. We will unset from a and set it to b. Why? Because that will decrease the difference, that will decrease the difference. Okay, so what we can do, that whoever is minimum, and whoever is minimum, we will set this bit in that value. So if b is minimum over here, so we'll set this one into this b, and we'll unset this a. Okay, we'll unset this a. Now again we'll check, maybe now let's say if this is all one, so a and b values, a is now smaller as compared to b, so we'll exchange the values. Okay, so now let me explain. As per the example given, a is 12, right, and b is 5 and n is 4. So let's consider all this into 4 bits. So it will be nothing but 1 1 0 0. B will be nothing but 0 1 0 0. Now n is 4, so we'll have to select some x, right, of 4 bit. And what should we select for this? For this, what can we say, that right now we'll have to make them come closer to each other, right? So 12 is so much greater than 5, like right now here the sum is 17. Okay, the sum is 17. So what we can do, if we want to have sum 17, and here we have 12 and 5, right, 12 and 5, this will give sum 60. But we know that for 70, what can we do, we can make one 8 and another one 9, and we can get a maximum sum of maximum product of 72. Here also maximum product of product was 60, so we can get a maximum product of 72. So what we'll do, we'll take some value from this 12 and we'll give it to 8, give it to 5. And we know that right now the difference is 8, because here it will have value 1 2 4 and 8. So this is the first bit. Even if in after all the bits the maximum difference can be achieved or settled down is 7, because we know that the sum of all the bits after this fourth bit will be 7. So the difference can be reduced by 7, but here it can be reduced by 8. So let's go with 8, because the difference will be decreased by 8. So if we'll see here, if we'll switch this, because a was greater, b was smaller, so what we will do, we will fix the smaller bit or put 1 over here, or in other terms what we are doing over here is making this 0, making this 0 and making this 1. Okay, now if both are ones, then we will do nothing. We can simply put 0 in the x, or we can leave a both the bits in a and b as 1. Now moving forward, here both are 0, so here what we can do, we can simply just put 1 over here, or in a itself we can make this bit set, and b as well we can make this bit set. Now so now at the last bit, if you'll see, the value of a has changed from a, the value of a has changed from what, 12 to just 4 plus 2 6, and the b has changed from 8 plus 4 12 and 2 14. Now here we are seeing that, again we have the same condition, like we have the total sum as 20, because if we'll shift change these bits, the sum will still be 20, but to maximize the product, here we have 16 and 40. But if we'll see who is the greater value, this is 14, so what we'll do, unset from the 14 and set in the 6, because in that case 6 will increase a bit and 14 will decrease a bit, and be we'll have two numbers closer to each other having some 20, so in that case we'll get greater product. Okay, so if we'll unset this, so it will become 0 and this will become 1. Okay, so the final value will become 7 over here. Yeah, the 7 over here, and here it will become how much, 8 plus 4, or 13, I would say 13, or how much, sorry, 14 over here. Okay, just a second, 8 plus 4 12 14. I think in the previous scenario I missed it. Okay, okay, earlier also it won't be sorry, here it was not 14, here it would be 8 plus 4 plus 12 plus 2 14, it was 15, sorry, my mistake. Here also it was 16, so it was 15, now it had become 7 and 14, and in this scenario you'll see we are getting maximum product, that is 98. Okay, so I hope the concept was clear to you. Just to reiterate, what we will do in both a and b, we will start from this bit, rightmost bit or the most significant bit. We'll check if both are 1 and 1, we will leave them as it is. If both are 0, what we'll do, we'll change them to 1. If if now if the bits are different, we will check. If this is a is still smaller, then we'll do nothing, left set bit in a and b as it is. But if let's say b is smaller, then this change this eighth bit or the bit in a as 0 and update this bit to 1. So we'll keep iterating till the last bit, and whatever the final value, we can simply multiply a into b. Why? Because we are already changing the bits as well, so we don't need to worry about this x, because why, we are already taking care of that while running the loop itself. Okay, now come to the solution is quite easy. Just a second, guys. Yep. So see what we are doing. We are just running a loop from n minus 1 to 0. Why? Because we know that this will be n bits. We are checking if the bits are first of all, we are just switching the minimum value to b. We are always switching that b is minimum value. So if a was greater, we are making b as, if a is greater than b, then it's okay. But if b is greater than a, then we are swapping a and b such that a is always greater than b. Now one more thing I would just point out, that see, if both the bits in a, or sorry, if both the bits are 0, it is a and it is b, and we know that b is smaller than a, so or we can write that a is greater than b. So if both the bits are 0, then also we will have to set both the bits, and finally it will result in setting up of both the bits. But if it was something like this, that in A it was 1 and B it was 0, then also we'll, what we can do, and we know that B is minimum, so we'll set this bit, so it will become 1, and if we'll try to XOR with this one, with this bit, it will result in 0. So what we can say, that whenever we have 0 in B, we can simply take XOR of that ith bit with 1, because if both are 1, then we don't need to worry about. If B is 0, okay, then we will see. Else if B is 1, then we don't need to worry about. Why? Because A was already greater, so we won't do anything. That's what I have done. If the bit is if the ith bit in B is 0, then we will just take a XOR with 1. Okay, and remember that B was minimum. So, and finally we can simply multiply our value and return the result. I hope this would be clear to you, but if you guys have any doubt, let me know in the comment section. Thank you guys. Yeah, let's try submitting this. Yeah, okay. I hope see you in the next video.